What's up, everybody? Let's cut the fat and jump right in. This is a manometer problem that gives us the pressure of the gauge on the left and asks for the gauge pressure of the gasoline pipe connected on the right. Don't let the 5 fluids in the tube fuck you up. Once you've done one manometer, you've done them all. So for these bad boys, the name of the game is pressure balance. It's pretty much just the fluids version of statics. So if you didn't like statics, sorry, homie. Let's break it down. First, start with the pressure of any side you want. In this case, we're going to start on the left where we know the pressure already. Then you add or subtract the pressure of the fluid piece coming from it based on the height. Rinse, wash, repeat until you make it through all the fluid columns to the other side. Finally, you set it all equal to the bulb on the other side of the tube, which in our case is the gas pipe on the right. All right, let's talk specifics. In fluids, there are different types of pressure, which can be super annoying, but it is what it is. For manometers, you've got 2 types, the terminal pressures and the fluid column pressures. The terminal pressures are the ones that are measured by a device and are normally what you solve for. The fluid column pressures come from the weight of the materials. Those guys are calculated with the formula rho gh. That's the weight expressed as a pressure, but don't worry about the semantics. I do recommend you remember this equation though. Anyway, rho is density, g is gravity acceleration, and h is the vertical height of the column. Quick tidbit, you see that SG of the fluids in the diagram? That's specific gravity. It's just a cheap ass way for the writer to try and wreck you. SG is density divided by 1,000. So take each SG and move the decimal to the right 3 spots to get the densities. As soon as I see SG, I just convert it immediately. But no, seriously, it's actually a shorthand comparison of fluids to the density of water, but that's none of our business. Oh, another thing, notice how the density of air is literally hundreds of times smaller than any of the liquid fluids? Yeah, air pressure is basically negligible because of that. Cheat code. Okay, so we know about the pressures, but how do we know whether to add or subtract a given fluid column? It's based on the displacement direction. We're going to hop from material boundary to material boundary. If a column starts low and ends higher, that's a pressure drop. It's negative. If a column ends lower than it started, that's an increase in pressure. Positive. It makes sense once you see it. Trust me. Don't believe me, just watch. Now that we have our info, it's application time. Plug in 370K for our left pressure gauge. I put 370 now, but I'll add the K later. This equation runs on standard pascals, but most fluids exert kilopascals, so you will need to write them as thousands. All right, so from the bulb reading, we pass through the air column. It starts high and ends lower, so the pressure increases. It gets a positive. Rho gh is the pressure of the air, but remember, it's going to be negligible, so I'm going to write it as 0. Pop the molly we sweat. Next is the water. Notice how I'm not using the curve of the tube in my height calculation. For the H2O, it ends higher than it begins, so it gets a negative. making sense yet. Yeah, I know. Now we just do it over for the next few materials and set it all equal to the gas pressure, which is what we want. Just be very careful when you're matching the height values to your materials. That's the most common mistake students make. Notice how I'm not using the curve of the tube in my height calculation. That's because in fluids the pressure is the same across horizontal cross sections. Basically the height displacement for the curved pieces is 0, so we ignore them. Use the stop point compared to the start point. All we have to do from here is plug and chug to get our answer. The gasoline pressure ends up being 354.6 kilopascals. This is a standard manometer problem, guys. Probably 80% of them will be like this. Just practice a few and you'll be eating these problems alive. Happy studying, y'all.